Hi, ladies and gentlemen. Today we're going to be taking a look at exactly what is a mineral. So we're starting a new unit here about minerals. We're moving from below ground to a little bit above ground, although some of this is a little bit in both places. But we're going to look at what a mineral actually is today. So let's go ahead and start with a definition. All right, this is going to be our scientific definition for mineral, and that is that a mineral is a naturally formed inorganic solid that has a definite crystalline structure. Well, that's kind of official sounding and maybe a little confusing. And so let's break it down into its different parts. All right. Once again, a mineral is a naturally formed inorganic solid that has a definite crystalline structure. Let's take a look at what that really means. Well, before we get into that too much, a lot of times when we talk about minerals, the word mineral and the word rock tend to be used together a lot. We talk about rocks and minerals and rocks. They are different, but they are also related. And we're going to be talking about rocks after we finish our unit on minerals. So we should probably talk about their connection. And that connection is basically that minerals are the building blocks that make up rocks. All right. Um, Rocks are made out of minerals and then other things um, that may be in there as well, other than just minerals. So uh, we could say that a rock is made out of minerals. However, minerals are not made out of rocks. All right. We'll talk more about that as we move into the idea of the unit of rocks as well. So, what exactly is it that makes a mineral a mineral? Like, what does a object, what does a substance have to be or be like to be considered to be a mineral? Well, we're going to use a really weird word that is not actually a word to help us remember the characteristics of minerals. And that word is snifk. All right, you can see that over on the left-hand side of the screen here, SNIFC, snifk. Well, the S in snifk stands for solid. All minerals are solids. Okay, the second one, and really, we're not going to talk a lot about what it means to be a solid. I think most of us have a pretty good idea. It is not a liquid, it's not a gas. It is in solid form in nature. Speaking of nature, minerals also have to be naturally occurring. Now, we can make things that are very much like a mineral, almost exactly like a mineral in a laboratory. However, it is not technically a mineral if it's made in a laboratory. It has to occur in nature. We might say that it has to be God made, not man made. All right, God made, not man made. In fact, I would add that to your notes. I'm not sure there's a spot for that directly in your notes, but find a spot somewhere to add God made, not man made. All right. Um, Inorganic. Minerals have to be solid, they have to be naturally occurring, and they have to be inorganic. Now, typically when we hear the word organic or inorganic, we tend to think of like fruits or vegetables or something in the grocery store. We know it has something to do with how they're grown. Don't know how much more we know other than that. Well, with minerals, it has a little bit different meaning. Um, the word inorganic means that it does not come from living things or it is not made by living things. So, organic has to do with living things. In means not, so it's not from living things, it is not a living thing. All right. So, minerals are inorganic. So, we've got the S, the N, and the I from sniff. Now we're moving. Oh, sorry, I forgot to put this up there for you. But so they're not from biological or living origins, origins meaning beginnings. So it didn't start out living or come from something that was living. Um, the F in sniff. stands for formula. Well, what do we mean by that? We're really talking about a chemical formula here. All right, it has a specific chemical composition. Here are some examples. Fe2O3 or NaCl, which is sodium chloride. That's the salt that you put on your food. Ag. Ag is silver. All right. CaCl2, calcium chloride. These are all minerals. These letters and numbers are what shows their chemical composition. In other words, what elements or chemicals are they made from, and how much of each chemical is needed in order to formulate that particular mineral. Now, there are certainly many, many things in this world that also have chemical formulas that are not minerals. But if it's solid and it's naturally occurring and it's inorganic and it has a chemical formula, there's a pretty good chance it's a mineral. However, we don't know for sure yet because we have not gotten to the k in sniff yet. So that last letter, the letter C, stands for crystalline. In other words, it has crystals. It has a crystalline structure to it. Basically, crystalline is the adjective form of the word crystal. And crystals have a predictable repeating pattern to them. All right. And each mineral kind of has their own predictable pattern or unique pattern. Uh, Crystals can be kind of diamond shape, or they can be kind of pyramid shape, or they can be really, really long and thin, or almost feathery in shape. Some of them are very block or cube-like. And it's those shapes that give minerals a lot of their special characteristics. Color, in particular, often is because of the shape or pattern of a mineral's crystals. Here's an example of what I mean by crystalline. So on the left-hand side, we have the mineral halite. And you can see its crystal form is very block-like or cube-like, and that is because of the way that the sodium and chlorine atoms are arranged in the halite. They are arranged with a very specific structure, and that structure causes the crystal in halite to have a very cube-like look to it. Glass is not a mineral because it is very random in the way that those atoms are put together. They don't have a very specific structure to them. Here are a few minerals and the different shapes that crystals can come in. You can see with the quartz, they're rather long and kind of pointy at the end. You have calcite, which has very flat edges to the uh, to the crystal and makes it look very cube or block-like. Here's some example examples over here. You can see with the galena, again, you have some smaller blocks. You can see with the pyrite that it again has a very distinct shape, and you can even see a pentagon shape in the crystals um, of the pyrite. So you can see that shape there. The beryl has a very distinctive shape too, with six-sided and then long sides here. Um, the stibnite is very interesting with its very skinny crystals, and the wolfenite with its very unique crystal shapes as well. All right, so ladies and gentlemen, that's as far as we're going to go today. Make sure that you have your notes filled in, and I hope that you have a great day.